You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem. Good morning, good afternoon, and good evening wherever you are. We're coming to you from Boston, Massachusetts. Today is March 12th, 2024. Hope everyone is doing well and staying safe. Bhavin, spring is right around the corner. You can feel it.
I know. I can feel it. Yes. Yeah. Let's go.
you say the same things.
Yeah, that's what happens when we talk for a long time, dude. Come on.
I know, right? I know. Well, I am always cognizant of second winter, though. We haven't had second winter, which is usually, what happens in the Northeast when you finally get days when it's 60 degrees, and then it's like Mother Nature says, "Haha, just kidding." Just kidding. It was some 30 degrees again.
I'm still hoping that I think this time for Groundhog's Day, the groundhog didn't really see his shadow.
Yeah,
So I'm hoping it's a short winter.
He said early spring, but do you trust a groundhog? Do you trust him?
Nope. Yeah, if I would that's not a good sign too. So nope, I don't trust a groundhog. But I can take some directions from people.
Hey, yeah, no, I'm hopeful as well. I'm ready for some warmth. We'll see. We might get one more snowboard day in my local mountain if they have enough snow, but
okay,
we'll go with it.
Nice.
So yeah, today we have an awesome guest, but and we're going to talk about some great stuff in the generative AI world. But before we dive into who that is and all that good stuff, we do have some news. So why don't you kick us off, Bhavin?
Yeah, sure. So I have a couple of acquisitions. Again, not big time mergers and acquisitions, but still relevant to the cloud native ecosystem. First one being Octopus Deploy acquired another startup called CodeFresh. The reason I found out about Octopus Deploy is because I knew what CodeFresh did. And now they got acquired by somebody else. So
how long has Octopus Deploy been around?
I have no idea. I didn't do that research.
I feel like not that old.
Yeah, CodeFresh was really early stages. I remember us discussing their pre-seed or seed round last year after KubeCon. So they are brand new. I don't even know if they have a bigger team. Might be less than 5 people. But they were building something cool around Argo, and they were one of the maintainers for the project. And
founded in 2012.
Octopus Deploy.
Mm-hmm.
Okay. So they are a big enough player, or at least have been around for a long time. It's interesting. I always thought they took the name Octopus because it had to do something with the number of sites and the Kubernetes logo. Maybe that fit, but 2012 there was no Kubernetes logo.
GitHub's an octopus too, right? So
that's true. Okay.
And CodeFresh was 2014. I was gonna say I remember CodeFresh when I was at Athena Health. So I was there. Yeah. So earlier, of course, companies' founding days are very different from when they actually take off.
Make some noise.
Yeah.
Okay. So Octopus Deploy officially acquires CodeFresh to boost its Kubernetes and cloud native delivery platform or delivery solution. CodeFresh has been an Argo maintainer figure in the Kubernetes CD ecosystem. Now, by integrating these two solutions, Octopus Deploy can expand their platform and offer that continuous delivery component or continuous delivery solution as well. As with all the acquisitions right now, we don't see any price. We don't see what the valuation was. Everything is just a big black hole. I'm just happy that people are finding exits in this weird market. Honestly, I'm still hoping for the IPO market to open up so we see some more exits from our CNCF or Kubernetes startups.
Sure,
but hopefully the Reddit IPO later this month, hopefully, unplugs the blockage, I guess, and we see a lot more IPOs.
We'll see.
Yeah, we'll see. And then second acquisition was another a smaller one, right? Previous guests on the Kubernetes Bytes podcast, KubeFirst, Jared and John, those guys got acquired by Civo Cloud. So I know Civo does offer a managed Kubernetes service, especially for the SMB space, and they have a really cool solution there. I remember seeing a couple of talks that were posted after their Civo Navigate conference last month, I think. But yeah, congratulations, KubeFirst team. Now they can still operate as a separate entity according to the blog post and the LinkedIn messages, and KubeFirst will still continue building their GitOps based solutions for different cloud vendors and cloud managed Kubernetes distributions. But now they'll do that after being like from under the CO family. So I guess congratulations to both the teams.
Yeah,
And then
yeah. I mean, we had John and Jared on what it was June last year,
June of last year.
talking about GitOps and authentication and all sorts of stuff. So if you haven't listened to that episode,
I
spoiler, you
know,
can
great plug.
go see what we were talking about back then.
Yeah, they have a really cool open source solution, right? That instantiates that entire cloud native environment for you using opinionated open source projects. So that was a good episode that we did. And then finally, for news for me, Cast AI introduced or launched their new Kubernetes cost benchmark report, and it definitely turned some heads on LinkedIn, or people were definitely sharing it with their own networks. I think the main part of the report was they analyzed over 4,000 clusters, and I know this is just to feed more information for companies like Cast AI or KubeCost, but out of those 4,000 clusters analyzed, they saw a really low CPU utilization and memory utilization across the board.
Yeah.
So like if you had like a 50 CPU cluster, that might be like a 5 node, 7 node cluster, people are only utilizing, let's say, 13% of the overall CPUs that were available to them. And then if you actually talk about scales, 1,000 plus more CPUs, that might be like a 20, 25 node a cluster at least, only 17% utilization. So people are not trying to
Wild.
utilize their Kubernetes clusters completely or failing to do a good job at it. This report made it evident, and obviously, since Cast AI is in this ecosystem, they have a best practices section on how you can use things like spot instances for your worker nodes inside your Kubernetes clusters, how you can use auto scaling, and some of the projects like Carpenter, which was originally part of AWS but now is an open source project, how you can right size some of the workloads that you're running through automation either provided by vendors or building something of your own. So if you are listening to this, go and check your own Kubernetes clusters. Maybe download a free tool. I know OpenCost is available. Run that, analyze your clusters, and see how you can save on cloud costs. So those were the three things that I wanted to share, Ryan.
Yeah, I mean, I think it's surprising, but not at the same time, right? I
I
mean, we
know.
saw this with cloud in general. So seeing it with Kubernetes and knowing how much effort the community is putting into metrics and monitoring
Yep.
and cost lately in the past year or two. Not terribly surprising. Also, just means I think we're at this point where we're really starting to care because
I know.
more and more shops, more and more data centers are running Kubernetes, and now we're like, all right,
Yeah.
we gotta rein this in. So yeah, it's a cool
Yeah. It
report.
wasn't,
Definitely go take a look at it.
as you
For
said,
me, I
right?
just
Like
had a
it
few.
wasn't really surprising, but like the surprising part for me was the percentage utilization, like less than
Yeah.
20%. That's a lot lower than what I anticipated. I thought like 50-60%, or sorry, 40-50%. But yeah, 17 and 13%, just too low,
Yeah.
man. Sorry, go
17's
ahead.
pretty, yeah, 17, 13 is pretty low.
Yeah.
But you know, we shall see how we do in the future, I guess, as a community.
Yeah.
um, just a couple quick news items from me. One is an article from Tech Radar really
Mhm.
talking about where customers are going, right? Given if they were VMware customers prior. I know this is something that probably a lot of people are starting to or in the middle of thinking about if you have a lot of VMware in your data center, in your shop,
Mhm.
because of all the changes that are happening to licensing and products, and the free is all gone. So basically, it's a really interesting article. Just reading through sort of the other alternatives out there, like Hyper-V and KVM and some other ones, and it really just kind of focuses on that. People are flocking that what they see in this
Mhm.
article, that is, to KVM-based, Linux-based. At least it says like two-thirds of the respondents sort of are KVM and Zen-based
Okay.
hypervisor alternatives. So I'd love to hear from our audience a little bit about sort of if you're dealing with this, right? Either reach out to us on Slack or send us an email from the
Yeah.
website. I'd really like to get a better sense of our community and what they're doing if they're involved in these types of decisions. It'd be really interesting to get some first hand feedback.
No, I think I like that, right? Like I know you listed Hyper-V and KVM as alternatives, like KubeVirt, dude. In the Kubernetes ecosystem. KubeVirt is another, I think, interesting
It's KVM at the end of the day, right?
solution. Yeah, it is. So like if you are already running Linux or KVM based VMs, like KubeVirt is like the perfect solution. I know we did an episode with Peter and Sachin from Red Hat last year around OpenShift virtualization. If you're already an OpenShift shop, like it's just an operator that you need to download, like it's, yeah, try it out and go listen to that episode as well. Another plug for us.
Yeah, there you go. I'm not doing it on purpose, I swear.
Yeah.
The next one, which I thought was super relevant for the episode today, which hopefully we'll get the episode out today.
Yeah.
There's a Tech Byte webinar from the folks at Google Cloud kind of talking about similar things that we did today, right? Which was, how do you get these GenAI sort of architectures with LLMs on Kubernetes. In this case, they're going to be talking about GKE, but how do you do it in sort of a simple and scalable, and these are their words, cost-effective way. Just I think some other resource in the community, and I think for those that are using GKE or have used that cloud in the past, definitely something maybe worth going and checking out if you get to it live. Probably actually because we were supposed to record this yesterday, I remember, and then I didn't. That webinar is today, so you will have to watch a rerun of.
Go find the recording.
But definitely, yeah, exactly. You can. I think you can watch it on demand in the same link that I will provide in the show notes. So definitely go check that out. Also, a little plug for Data on Kubernetes Day in Europe. If you are going to KubeCon, and hopefully you signed up for a DOK day, because it is a great place to go talk about data on Kubernetes and with some awesome talks for a Day Zero event. It should have been free to sign up when you had signed up for KubeCon. So I don't know, sometimes there's a way for you to kind of like go check out the DOK event, and if the room's not full, maybe you can get in. If you didn't sign up for it, I wouldn't discourage you from trying to show up and saying hi to those folks and seeing how that day is going. So definitely go check that out. If you're in Paris, Bhavin and I will not be, right? You're not.
I know. I'm sad about that, dude. Like not.
I'm sad about it too. It's like the first one. We at least one of us isn't going to be.
Hasn't been. Yeah. So if you find if listeners of this podcast find anything interesting, like share it with us. Like we'll do a news recap like we always do, but this time it's truly going to be like a virtual experience, and what we learn from the conference through social media or through blog sites. But yeah, if you find something interesting or pictures to share, tag us and we'll include that as well.
And then the last piece of news, I guess you could qualify it as news. I saw the CNCF had a new certified Argo project associate, Kappa.
Nice.
Basically certification's good for 3 years, but I think more and more folks are starting to get used to the GitOps workflows, and Argo is a great tool in this space. We've talked about it before on the GitOps episode, third plug, there you go. But this Kappa certificate is interesting. I think as we saw with tons of, with the Kubernetes administrator or the application developer or the security one, to see sort of one specific to Argo and GitOps, really cool. So go check that out. It's only, I think, $250 is the exam. So pretty reasonable. All being said, and you'll come out sort of an Argo expert, so to speak. That's what I had for news, Bhavin.
Okay, let's introduce the topic and bring on our guest.
Sounds good. So we have GenAI with Jani today, and Janakiram MSV, who is an analyst, advisor, and architect. You may have seen a bunch of his articles, maybe on Forbes or the New Stack or those kind of things. He is very active in the community and really, really knowledgeable. So we're excited to have him here on the show to kind of dive into what it looks like to get sort of these generative AI architectures set up on Kubernetes and what that really means with the different layers. So, without further ado, let's welcome Jani to the show.
This episode is brought to you by our friends from Ilotil. Ilotil Luna is an intelligent Kubernetes cluster autoscaler that provisions just-in-time, right-sized, and cost-effective compute for your Kubernetes apps. The compute is scaled both up and down as your workloads demand change, thereby reducing operational complexity and preventing wasted spend. Luna is ideally suited for dynamic and bursty workloads such as dev test workloads, machine learning jobs, stream processing workloads, as well as workloads that need special resources such as GPUs or ARM based instances. Luna is generally available on Amazon EKS, Google Cloud GKE, Azure AKS, and Oracle OKE. Learn more about Luna at elotel.co/luna and download their free trial at elotel.co/luna-free-trial.
All right, welcome to Kubernetes Bytes, Jani. Why don't you give a introduction of who you are and what you do, and we'll jump right in.
Sure. So I am essentially a market research analyst based out of Hyderabad, India. I do two things. One, I analyze the market trends and I publish my content at Forbes, the Newsstack, InfoWorld, some of the media outlets. And my second line of business is working with startups and platform companies as an advisor. So I work with the CMO and CTO, defining the product roadmap and also working on the outreach, evangelism, and developer outreach, essentially. So those are two roles that I play.
Yeah, you are a person with many hats, as they say. I can vouch for that. Working with you in the past, if you don't know what Johnny's been up to, just go Google his name basically, and he's got such great content out there. So hopefully we'll get in a little sneak peek of what you've been into in the Gen AI space today. So we're here to talk about Gen AI. So Bhavin, I think we'll kick it off.
Yeah, I'll kick it off, right? Jani, like I think I like the name of this episode. I don't know, Ryan, if we'll end up choosing this, but Gen AI with Jani is what we called our notes.
It does flow real well. Yeah.
That's like a perfect topic. But let's start there, right? Like there has been a lot of buzz around Gen AI for the past year and a half now since GPT-3 came out the door. Can you give us like an elevator pitch, like a level set for our audience, right? Like what is Gen AI? What does it include? What are the different types of assets that you can generate using these new LLM models?
Right. So to set the context and to make sure that the cloud native community is on the same page, I just want to briefly talk about the evolution and what got us to Gen AI. Right. So I actually saw three different milestones in the evolution of AI. So the first milestone was very simple machine learning, which was essentially done on CPUs and any desktop PC. The favorite framework was scikit-learn, and all you could do was linear regression and logistic regression. Basically predicting a future number or classifying something. So that was the first milestone, and a lot of work has gone into it. A lot of Python developers used pandas, NumPy, scikit-learn, and that in itself was pretty powerful. That was the first generation of machine learning and the initial AI. And then the second phase was all about neural networks. And that basically took the basic machine learning and traditional machine learning to more sophisticated neural network algorithms. And we had things like computer vision based on convolutional neural networks, and then the reinforcement learning, the recurrent neural networks, more sophisticated techniques like LSTM, long short-term memory. So that lasted for a while. I think for about 4 or 5 years, AI was typically meant using neural networks. Then the third phase or the third generation is what we are currently experiencing, and this is generative AI. So there was a very abrupt, overnight transition from neural network to the transformer network. And that opened up doors to generative AI. So what is the difference between the previous generation versus the current generation? Well, the traditional AI was all about predicting, right? It was all about predictions. Machine learning and AI was used for anomaly detection, predicting fraudulent transactions, classifying dogs versus cats, and hot dogs versus burgers, stuff like that. So it was all about either prediction or classification. And then generative AI took that to the next level, and the uniqueness of that is the ability to generate content, which we are now seeing through chat GPT and multimodal,
Mhm.
stable diffusion and tools like, the mid journey runway. So when AI is able to generate content and reproduce content, it reached the masses. That was the inflection point where
Mhm.
everyone saw value in AI, because it was not confined to academia, it was not confined to researchers, it was not confined to very niche groups, but it suddenly became highly relevant and everyone was in awe because it just influenced and impacted almost everyone's life, because it could generate content. And that means a lot for marketing folks, for copywriters, for content producers, creators, influencers. Everyone literally got impacted by this. So the fundamental difference between generative AI and the previous generation of AI was, predictive versus generative. So today we are living in an era where AI
Mhm.
can generate a lot of content, which is just mind blowing.
Yeah, it really is fascinating, especially when you think about, I think a lot of people, when they start thinking about AI, they think of something like the Turing test, which was what, the 1950s, right? Where we were, that was a long
Yeah.
time ago at this point. And, it's gone through, like you said, a lot of iterations. I think, people know the terms machine learning, they know the terms deep learning, but maybe aren't as familiar with or in excited about what those things were because they didn't get to interact with it. I think that transition to the consumer, right,
Yeah.
was the biggest reason why I think a lot of people started to really latch onto it. Although I think there also is sort of a downside, right? A lot of us maybe grew up in a way where we did work with chatbots that were terrible, but they weren't really backed by these new generations of LLMs, right? So we might have some PTSD working with some of those too. So, I do want to change the topic to focus on the cloud native, the Kubernetes side, because I want to make sure we hit on that mostly for this podcast. So, the term Gen AI, and as you described, what does it mean to the cloud native community and Kubernetes? Like, where does it fit in?
Absolutely. So that's been my focus for the last 8 months to a year. And I see two different categories where Gen AI and cloud native have very symbiotic relationship, right?
Mhm.
So first, the short term tactical opportunity is how do we exploit the cloud native infrastructure to serve Gen AI models and make the researchers, engineers, developers' life easy, right? That's what
Mhm.
Kubernetes is meant for.
Mhm.
So, Kubernetes, as Kelsey Hightower called, is the platform of platforms. And
Sure.
today
Yeah.
we are, seeing the real implementation, and that entire analogy becoming very, very concrete and realistic with platform engineering and all of that.
Mhm.
So, just like Kubernetes has become the platform for application development, Kubernetes is a platform for generative AI, and it
Mhm.
means quite a few things. So, as infrastructure architects and infrastructure engineers, how can we simplify the life of a Gen AI researcher, a Gen AI engineer, and a Gen AI app developer? How
Yeah.
do we become relevant to those personas? What can we deliver to them to make them more productive and more efficient? That is the first opportunity for cloud native community. So for that, we take the building blocks that Kubernetes already offers, and then
Sure.
we have these serving layers, and we have these vector databases that are coming in, and we run these agent infrastructure, expose endpoints, bring in
Mhm.
service mesh, bring in observability, all the goodness of cloud native with that added flavor of Gen AI specific platform layer, the platform stack. So Gen AI platform stack has some essential building blocks like, the GPU operator,
Yeah.
the shared storage layer, and then it has for example, a highly available vector database. It has an embedding model that is exposed. It has one or more LLMs that are exposed, and then there are some web apps, that run in batch mode behind the scenes, pulling the data and updating and refreshing vector databases and so on. And then ultimately, the topmost layer is the developer experience layer that is going to be exposed to the consumer, who is the ML engineer or researcher or the developer. So that is the tactical short-term opportunity for the CNCF community. Now, in the long term, we are going to see something very interesting. So LLMs, the large language models, are becoming the brain of applications, control planes, and infrastructure. I'll give you a very classic example, right? So today, if you go to ChatGPT and give some examples, like FedEx is a logistics company, Apple is a technology company. What is, for example, what is Emirates, right? Now it looks at these two. It's called few shot prompting, right? So it looks at the examples and then it figures out you're actually giving the company name and the category, and it automatically says it's an airlines company, right? So it is able to do that with the pre-training. Now imagine you do this few shot prompting to an LLM, and you put that LLM next to the Kubernetes control plane, and you actually create a prompt to this LLM saying, when Kubernetes events and logs are emitted, pass that through the LLM and automatically classify them into the severity levels or whatever labels you want to give. So now the LLM becomes the brain. Literally, it becomes the L1 engineer sitting next to the Kubernetes control plane. And with a little bit of plumbing and connecting the dots, you can even raise a Jira ticket when this LLM classifies one of the log outputs, and it detects that there is a problem, and it automatically goes ahead and raises a Jira ticket and flags off a support engineer who can take an action. Right? That is where we actually see AI ops coming into the play. So there is a misnomer in the community that AI ops is running AI on cloud native ops or DevOps. No, it is not. AI ops is infusing AI into ops. And we shouldn't be confused between ML ops and AI ops. ML ops is the infrastructure, and ML plus ops like dev and ops. AI ops is infusing AI into ops so that we are more efficient and we bring in this autonomous operations into the picture.
Yeah, I think that's a super exciting place for at least the system side, the operations side for AI. A lot of people, like we said, do use it from the consumer side, and I think we've had Runwin on the show here and Kate's GPT, right? Some people might be familiar with those names. They're really thinking about this problem and trying to make products or projects out of it, and I'm excited to see where that goes. Obviously, in the future, hopefully where we can work alongside it and it doesn't, take our jobs. But
no, it doesn't. But it just makes us more efficient. So the LLM infusion to control planes. I take example of Portworx because I know the architecture pretty well. The storage control plane, which is common for any storage engine on top of Kubernetes, it emits lot of logs, lot of data that is coming out of the regular. If the engine is humming together, it is emitting a lot of logs, right? Now, you can define certain maturity levels. The first level of maturity is just connect this LLM to a knowledge base, which is living in Confluence or somewhere. And you basically identify what is the error, look up the knowledge base through RAG and say, hey, this error has occurred. Here is the knowledge base, go do something with it. And you're literally getting human in the loop, right?
Yeah.
Now, the second level of maturity is autonomous clusters, taking autopilot to the next level. Again, giving the example of Portworx that all three of us are familiar with, PX autopilot, take it to the next level where this LLM not only informs you, but it actually remediates, right? The classic problem with Portworx is HD ports are not open and each node is not able to talk to the other, right? Sure. It's a classic newbie problem when you're installing Portworx. And it is obvious, when I actually look at logs, it tells you clearly that HD is not able to talk to each other, and the nodes are not communicating, which means you got to open 2379 port, as simple as that. But it might really create a havoc for someone who is doing it for the first time. But imagine this LLM assumes an IAM role if it is running in AWS, goes ahead, calls Pulumi or a Terraform a script to basically open these ports. Boom, Portworx starts working, all the three nodes are up. That's auto remediation, right? So that's where LLMs will get to.
No,
Yeah.
I'm sure I'll take this feedback back to the product team. Guys, we need to work on this.
Yeah, and I mean, there's so many of these. I
Yeah.
think this common problem where in the configuration, the day one journey, right? Of AI can really help you get off the ground because there's a lot of knowledge and people have done that before, right?
Mhm.
Where it can pull from and kind of remediate. There is maybe a little bit of danger of like things just magically start working and maybe you don't have all the back end knowledge now to know what it did. I mean, that's maybe a separate part of it is like, okay, if it takes a remediation step, it should let you know, hey, I did this,
Yeah.
right? And that's the kind of, I guess, other side of it.
Gotcha. And so, Jani, like, thank you for discussing that, right? Like, I like Ryan's question in the first place. Like, it gives us an idea or a strategic overview of how AI or Gen AI specifically can be relevant to cloud native or Kubernetes workloads. But like next question, I want to get more tactical, right? Like how do you, like you listed a lot of things. You listed vector databases, you listed how models can be deployed. Can we get tactical and talk about some of the tools that you might be using in your home lab to get these things or get these models deployed on Kubernetes? And if you can also cover like, is Kubernetes only relevant for serving these models? Because I remember seeing like an OpenAI talk from like a few KubeCons back where they were actually training you using Kubernetes as well. So I would want you to talk about how Kubernetes is relevant in different stages and what are some of the tools that you recommend.
Right. So, to set the context, in my home lab, I run two massively powerful PCs. Now, each PC runs two RTX 4090s. So that
Nice.
means I have four GeForce RT90s. And these two are two individual machines, they are independent. And I run a single node Kubernetes cluster on it. So the
Mhm.
reason why I invested, and in India, I could have bought two mid-range sedans instead of those two machines. It
That's
costed
funny.
me a fortune.
Yeah.
But why did I invest and why did I really had to go through it? Because
Mhm.
today, the biggest challenge is take any hyperscaler, take any
Mhm.
region, take any
Mhm.
zone, you cannot get a GPU instance on demand, period.
Yep.
Yeah. Or at least it's hard, right?
Right?
Yeah.
Forget about H100 or whatever
I
is the
know.
state
You'll
of the
get
art.
the most
Even
basic GPU that doesn't really help you with much. Agreed.
exactly. So that's been my frustration. So I'm a big advocate of cloud. I believe in this whole argument of capex versus opex, but I had no
Mhm.
choice because I could never get a hold of any GPU instance. So the next best thing was to handcraft one and assemble one for myself. So I have gone ahead and assembled
Mhm.
it from the scratch. I got the most airy cabinet. It is almost like a mid range. It reminded me of some of the Solaris machines that I have seen in my college.
Right.
So they are massive. Um, so I got that and then I installed, and trust me, it's a pain to get two GPUs plugged into the motherboard because these motherboards are not server grade. They are Asus or
Yeah.
MSI or one of
Yep.
those, and they are not meant to run two GPUs. They barely manage to get one GPU up and running.
Yeah. And the
So
GPUs are huge too.
right,
Yeah.
they are, each GPU is like 3 kgs or something. So I had to get additional stands, and it's a hack. But I managed to get
Mhm.
two of them in one chassis, in one cabinet. And then I installed Ubuntu 2204.
Mhm.
Um, I installed NVIDIA drivers. I installed CUDA. And the moment of truth is NVIDIA SMI, and it shows
Yep.
up both the GPUs. You
That's
know,
awesome.
so my son, who is currently in his third year engineering, was helping me, and both of us started from the scratch. We unwrapped the motherboard, we unwrapped the Intel CPU, the i9 14th gen, and from there to installing Ubuntu and installing NVIDIA drivers and typing NVIDIA SMI was like a moment of truth. We celebrated at 2 a.m. Finally, when we got
As
to
you
see
should,
that.
yeah.
So it started from there, right? So once that
Mhm.
was available, I installed Docker, I installed Container D, and then I
Yep.
installed the NVIDIA Container Toolkit. So NVIDIA Container
Mhm.
Toolkit basically exposes the underlying CUDA and NVIDIA drivers to
Mhm.
these container runtimes, the Docker engine and container D. So
Gotcha.
the next test validation is you basically do a Docker run, GPUs all, and
Mm-hmm.
container, the runtime is NVIDIA container runtime, and then you do an NVIDIA SMI through the image, Ubuntu image, and then Docker actually shows you NVIDIA SMI, which is next checkbox to
Yeah.
click,
Right.
right? Which means
All the
now
plumbing is there, right?
exactly the containers are able to see the GPUs, which is fantastic. So the next step is installing upstream Kubernetes. I had trouble with RKE2, K3s, and other flavors, so I believe
Hmm.
in installing upstream. So I installed a single node Kubernetes using Cilium as my CNI,
Mm-hmm.
and the basic stuff. And then to make Kubernetes talk to this container runtime, you need to install the NVIDIA GPU operator, which is the next step. Right. So NVIDIA GPU operator bridges the container runtime with the Kubernetes. Basically, it's the thin layer between kubelet and the underlying runtime.
Gotcha.
Uh, so now the next phase is you take an Ubuntu 2204 image and run it as a pod and check NVIDIA SMI.
Hmm.
Okay,
So,
so now you have like three layers of abstraction.
so Jani, a question, right? So you said you installed the Docker toolkit for NVIDIA, and then you also installed the GPU operator.
Yeah.
I know, like, does the Kubernetes, like, I know NVIDIA has a device plugin for GPUs
Yeah.
inside Kubernetes. Does that help consolidate some of these things, or that's a different thing completely?
Yeah, so there are two techniques, and this is very important to call out. I'm actually going to document it. So there are two
Mm-hmm.
ways, right? One is my requirement is very simple. Kubernetes runs as one of the processes, but I want to download a model from Hugging Face and write a PyTorch program
Hmm.
directly. So I
Okay.
don't want to go to the GPU via Kubernetes. I want Kubernetes to be readily available at the OS level. So
Mm.
I did everything to get to that point, right? So after that, to really connect Kubernetes to this, you can use device
Mm-hmm.
plugin. So device plugin is just the bridge between whatever you install. Like you get complete control of the CUDA runtime, the NVIDIA
Yep.
device driver, and then you take it to the device plugin and you basically surface it to Kubernetes. That is uh, very easy to install, and Kubernetes doesn't. NVIDIA's software, doesn't meddle with what you already installed. It just uses everything below the stack.
Okay.
But if you don't want to go through this process and you don't mind if CUDA is not available at the OS level and it is only available through Kubernetes, the easiest is to use the Helm chart of NVIDIA GPU operator.
Hmm.
And
Okay.
that does all the heavy lifting. It basically does all these steps, but it does behind the scenes. You had to reboot once and boom, it just brings up everything. But the side effect of that convenience is if you want to really run a Docker container or if you want to directly access the GPU with code, you cannot because Kubernetes
Oh,
locks everything.
takes control of it. Okay. Okay, that
Yeah.
makes sense.
And if you change a subtle configuration, it breaks. So it's
Okay.
very
Yeah.
brittle. It's a very, very, very fragile installation when you go through operator. So I don't prefer operator because it's a black box.
Mm-hmm.
And you can do that when you are running like a completely automated bare metal install where you don't care what OS you are running. You are using a thin OS like Flatcar Linux or something like that,
Yep.
and you don't really care. But if you are using that as a dev machine and also a single node cluster, I recommend using the device plugin because it gives you best of both.
Okay, and I know that I'm just taking us in a rabbit hole around NVIDIA
Let's go.
plugins, but can we, like, I know the device plugin allows you to time slice, and if you have the compatible GPU, do like multi-instance GPUs. Does the Docker version or like the Docker toolkit allow for those kinds of GPU sharing algorithms as well, or that just gives you control and you can do whatever with you want with it?
So it's a very important aspect.
Hmm.
Now, a Docker container or a pod will basically assumes that it has 100% access to the entire GPU and it just occupies whatever you give.
Okay.
Okay, so what happens is the moment you load a GPU enabled model, for example, when you point Docker to NVIDIA container runtime and launch a container and look at
Hmm.
NVIDIA SMI, very quickly 100% of memory goes to this single container.
Yep.
And after that, when you try to launch another container, you see the dreadful message and the container crashes.
Yeah.
Yeah.
So it's very hard. Now, what I do is I restrict my Docker images, containers to one GPU. That's the reason why I run two. So when
Okay.
you actually set this environment variable that says CUDA visible device is equal to 0, you basically expose, you restrict the runtime to see only one GPU.
Okay.
So I set that
Okay.
environment variable and then I run the Docker container. Now it quietly restricts itself to the first one. And then I use CUDA visible device is equal to 1 and I run another model.
Right. Okay.
And
Okay,
where do
that
you
is
set these
the
environment variables? Like on the
it
OS
goes to
level?
the no, it goes to the container image. Most of the
Okay.
inference engines, most of the CUDA based images respect this flag.
Okay. Gotcha. Good to know.
But
Thank you.
you cannot really say 0.5. You cannot say CUDA visible device is 0.5 and expect the
Yeah.
model to take only 12 GB out of 24 GB and leave the room for other. No, it doesn't work that way. That is the biggest problem. So it also depends on your inference engine. I'll come to that a bit later, but
Sure. Yeah.
the hard fact is, unlike CPU cores, you cannot share CUDA cores across containers. That is a
Right.
big problem. There is no solution. Intel, AMD, and NVIDIA are working with the Linux community to bring support for C groups and basically treat GPU like CPU and have those limits and requests and that whole model, bringing that to GPUs. But currently, it's not there yet.
Right.
Gotcha.
Right. That makes sense. I mean, I think, we're used to that kind of configuration. If you've been working with Kubernetes or containers for a while, maybe you'd expect that, but we're still early days, right? The
Yeah.
reality of it is we're still early on. So, all right. So looping back around, so you have exposed your GPUs to your Docker environment, to your Kubernetes environment. Now what? What do you run on this thing? Where do you get
Yeah.
started?
Yeah. So, the funny thing is, throughout my life, there is one piece of the stack that forces you to go grab a coffee and stare at the monitor, right?
Okay.
Yep.
So I think I worked for Microsoft for about 11 years. So installing .NET and Visual Studio was that coffee break moment.
Nice.
You push this DVD, double click, installer,
Nice.
and yeah, actually not one coffee. You got to have 3 coffees before it finishes, right? So from there we went to npm install, and npm install used to take some time. And then we had Docker pull was taking
Right.
decent amount of time, giving you some thinking time. And now after we figured out how to do caching and networks have become faster and Docker has matured, all of that, now the coffee break moment comes when you're pulling a model from Hugging Face.
Okay.
Yep.
Well, what's Hugging Face? I'm sure some of our listeners just probably heard that name and said Hugging Face. That's
Yeah.
a strange name. Yeah, could you explain that a little bit?
Yeah, absolutely. So Hugging Face is to foundation models what Docker is to container images, Docker Hub.
Gotcha. Okay.
Okay. Just like if you don't do anything, if you don't point to any registry, if you do a Docker pull, it goes to the library.index.io, or there is a standard URI, and it pulls
Yep.
the
Public
image from
endpoint
that.
for Docker Hub. Yeah.
Exactly, right. And same thing when you're done with your Docker login, when you do a Docker push, it automatically talks to that endpoint. So similarly, Hugging Face has become the new de facto endpoint for sharing artifacts related to generative AI. So there are foundation models, which are the base models, like Meta and Databricks, Google. All of them are training these foundation models. Like Llama 2 is a foundation model.
Mhm.
Gemma, recently from Google, is another foundation model. Databricks, Dolly, Falcon. So where is the repository for all of this? Where is the Docker hub for these foundation models? It is Hugging Face.
Got it. Got it.
Gotcha.
And those are pre-built. You know, obviously, you can go peruse and see what kind of models you're interested in, basically.
Absolutely. And they are way bigger. For example, a 70 billion parameter foundation model will be close to 17 GB or 20 GB. So
Yeah. So
it's
there's your
massive.
coffee moment, like you were saying, right?
Yeah, yeah. But Hugging Face is more than just a repository for models. It is also a repository for data sets, because models and data sets go hand in hand, right? So,
Yeah.
for example, if I curate a data set, I'm just making it up. For example, all the logs of Kubernetes, and I create a data set.
Mhm.
Uh, how do I share it with the community? Well, I upload that to Hugging Face, and it sits in the data set section of Hugging Face.
Okay.
So you go to my username, Janakiram M/, you can actually pull the data set, pull that foundation model, pull that fine-tuned model. So it is basically the hub for all the artifacts.
Right. Now,
Gotcha.
speaking of data sets and pulling these large models, obviously this takes some sort of storage, right? Some sort of integration of where you put these things on Kubernetes near Docker containers. What does storage look like in this GenAI infrastructure, right? Are we using block? Are we using file? What do our databases use? Let's dive into that a little bit.
Right. So these models, as I mentioned, are massive, right? They are, and it's not a best practice to containerize these models. It's a bad idea. You shouldn't take Llama 7B and put that in a Docker file and package that as
Be
an
a
image.
big container image, yeah.
It's a bad idea, right? So you need to decouple the model from your inference code, which is basically consuming the model. The reason for that is your inference code is stateless, whereas the model is stateful. They need to be decoupled. They shouldn't be when you scale out your inference engine, the model shouldn't scale out. It's a nightmare if you are attempting to do it, right? So
Right. Okay.
that actually points us to a very unique aspect of the storage layer. So now imagine two layers, right? One is the static storage layer where the models are optimized for read only, read access. And then you have this inference engine that is scaling out itself to all the available GPU nodes.
Mm-hmm.
So, how do we bring models, to every node? Now, again, it's not a good idea to replicate these models on every node and cache them. They are massive, right?
Right.
So we need a shared storage.
Okay.
So a shared storage layer that is available on every node, and it is exposed as a very well-known consistent endpoint. So we don't have to, first of all, download the model on every new node every time we scale out. Second thing is the start time of the container is not really blocked by this model.
Right.
So we decouple that.
Okay.
So the storage, yeah.
No, I think I'm more of a basic question, right? Like I've gotten this question from some of the people that I work with. Like, okay, the models exist on Hugging Face. We can pull them down locally on a Kubernetes cluster. Models need the memory that's inside a GPU. So, like, I'm pulling it
Right.
down. I'm loading it on the GPU. How does
Right.
persistent storage come into the picture, right? Like, is it stored in the PVC and then it's running on the memory of the GPU? Like, how does that workflow work?
Yeah, so models are just blobs. They are basically a set of arrays that are serialized and stored on the disk.
Okay.
Uh, so when you load them, technically what happens is you are deserializing this blob, and then you are spreading that across available GPU cores, either a single GPU core or multiple cores of multiple GPUs.
Okay.
So it is as simple as, you basically serialized a massive array which contains some data, and you uploaded that to Google Drive. I downloaded that, and now I deserialize it and load it to the memory, and I start playing with it. That's exactly what happens when you pull a model from Hugging Face,
Gotcha.
load
Okay.
it into the inference engine. So loading that into inference engine is basically this process where you unpack the blob and spread that across available CUDA cores of the GPU.
Okay. So then let's create a random scenario, right? I have an air gap cluster. I pull down the model once in a cluster that's connected to the internet from Hugging Face. I have a volume, right?
Yeah.
We all know how snapshots inside Kubernetes work. Can I, instead of inside that air gapped environment, instead of pulling it from Hugging Face, can I just create a new volume from that snapshot and I have a model running? Or that's not really how it works?
No, the better mechanism is to use something like, if you're running it in the cloud, use something
Mhm.
like EFS,
Okay.
right? So you basically download your models to an S3 bucket. This is purely for the cloud.
Yeah.
And then you write a batch process to download whatever is cached in your S3 bucket onto your EFS, and you mount this EFS on every node,
Okay. Okay. Gotcha. Okay.
right?
So if I
Uh,
want to download the same model on different clusters that I have access to, I at least have to pull down the model once. I can't just copy or have my storage transfer the models between clusters.
no, that's not a good idea.
Okay.
So all the nodes should have a consistent shared storage layer.
Yep.
Uh, and these models are 99% of the times are read-only versions. Unless you are
Gotcha.
fine-tuning them, you don't need
Yep.
to touch them. So uh, at least in my home lab, I have a NAS, right? And
Mm-hmm.
that is my pass-through proxy for Hugging Face. So what I do
Okay.
is I basically wrote a cron job that synchronizes Hugging Face with my NAS once in 2 days to get the recent revision. Just like
Yeah.
Docker images have tags, uh,
Mm-hmm.
these models have revisions. So occasionally these revisions are pushed and updated, and you need to have them locally. So what I do is I basically sync my NAS with Hugging Face for a dozen models.
Okay.
Now, on Kubernetes, I use an NFS provisioner to simply mount my NFS
Um,
mount point into my Kubernetes, and
Okay.
I have the same models available.
Okay. No, thank you. That
that
makes
that
sense.
way that way the model's available, and now
Yeah.
it's up to the sort of application side or the inference side to kind of load that in and kind of create whatever that application might be doing, so to
Okay.
speak. So
Exactly.
yeah.
The beauty of this approach is, let's say Meta has launched a new revision of Llama and I want to use that. I just set the deployment to 0, terminate all the
Yep.
pods, and set the deployment to 1. It picks up the most recent model,
Gotcha.
Right. Right.
Okay.
right?
So I know, like when we were dealing with container images, we had projects like Harbor, which were pulling down recent versions and caching them locally near the cluster. You wrote
Right.
your own cron job, but are there any projects or something that the community is working on to make sure that these models are accessible locally as well? Or even if I wanted to create like a private repository of my models that I'm training in house, I know open source models is a different thing from all these different vendors, but if I'm building
Right.
a small language model inside my own enterprise, can I
Yeah.
host them locally? How do I do that?
So very interesting. Just like a decade ago when Kubernetes came out, there was no
Hmm.
concept of a private registry,
Yep.
right? Docker actually had an image which was called the private registry, and you could expose it,
Right.
and it again pointed back to the file system.
Okay.
And that's all we had. That's how you basically managed private registries. And then came in Quay from CoreOS, now which is a part of Red Hat, and then we
Yep.
had Harbor. So similarly, there is a need for a model catalog
Hmm.
Right.
living on top of Kubernetes. We don't have that.
Mhm.
Yeah. Okay, so anybody, if
So
in our listeners, if they are working on this, you need to give us a share of the new startup, right? No, I'm just kidding.
yeah, so see, now we have reached a point where projects like Harbor are smart enough to automatically sync the images with your public registry, do a pass through, do a proxy,
Yep.
mirroring. You can do a lot, but unfortunately there is no model catalog. See, if you look at what is going on in the public cloud and try to replicate that on-prem with Kubernetes, every hyperscaler offering GenAI as a service has something called model garden,
Mm.
Yep.
right? Bedrock has one, Vertex AI has one, Azure OpenAI has one. Now, these model gardens are essentially the repositories of models, and you can browse, you can pull, push.
Mhm.
NVIDIA has one in the form of NGC, the
Yep. GPU cloud.
NVIDIA GPU cloud, right? Now, none of those are available in an open source version or a cloud native version that you can deploy and say, hey, here are my Hugging Face credentials. Go pull everything and keep them in sync. Nope, we don't have that.
Yeah.
Okay.
Sounds like a good opportunity for a lot of these IDP folks we keep talking about,
I
right?
know.
Kind of build in this sort of thing. Well, I mean, that's great. I do want to get back to so that we're at the point now we've exposed GPUs, we have containers
Storage.
able to get them, we have models being pulled down and put on shared storage. Now, how do we go about the other side of that? Meaning, we have that model on shared storage. What is that application side of things look like? Right, use the word inference side, but
exactly. Exactly. So how do developers consume these models, right? Now, imagine you are corporate enterprise IT. You want to expose model as a service to your internal customers, right? So these models are just artifacts. As I said, they are just blobs. So the most important layer that exposes and interfaces with these models is the model serving part of it, the inference engine, right? Now, in the second generation of AI, we had a bunch of them, like Kserve of Kubeflow, one of my favorites. You could do that with PyTorch. NVIDIA had TensorRT and Triton, which was their native inference engine. And then Bento ML was one. There were a bunch of those serving engines that were available. But unfortunately, none of them are optimized for LLMs and foundation models.
Yeah, right.
So we have a whole new breed of LLM inference engines. And what they do is they basically expose a consistent, well-known API to the outside world, and internally they deal with the model management.
Gotcha.
And they're not
like Olama, I think, is one of those guys. But I know, continue with your answer, but I just wanted you to share examples as well, like what these tools
absolutely.
are.
I'm coming to that. I'll list the top of my mind inference engines. So my favorite. My favorite inference engine is from Hugging Face. It's called TGI, Text Generation Inference. It's open source. And the reason why I like that is, first of all, it's proven. Hugging Face professional offering of inference as a service is running on TGI on Kubernetes. It's proven. So Hugging Face, they eat their own dog food and they use TGI to expose their own endpoints. So that is proven container infrastructure, number one. Number two, Hugging Face make sure that the most recent model is optimized for this inference engine, right? If you go to Hugging Face and look at any model like Llama or Gemma or Falcon or Mistral, there are tags describing what the model is capable of, like text generation, chat, and instruct and so on. And there they put a label that says text gen inference. And as soon as you see that tag for that model, it means it works with the TGI container, which is fantastic.
Oh, okay.
And Hugging Face keeps the models and this TGI compatibility in sync. Like, when Gemma got released 2 weeks ago or 3 weeks ago, Hugging Face very quickly updated TGI to make sure it supports Gemma.
Gotcha.
Right. Okay. Yeah.
That is the second reason why I really prefer that. And third reason is it's very, very convenient and well documented. It's an open source project. It's written in Rust. You go to the GitHub page, you understand all the parameters, and it has a couple of keys, which are my lifesavers. So it has a CUDA fraction flag. When you are launching this container, you can set an environment variable that says CUDA memory fraction is equal to anywhere between 0 and 1, which means you are able to restrict the container to a percentage of your VRAM of the GPU. That's a lifesaver for me. So on a 24 GB GPU, which is RTX 4090, if I am launching a Llama 7B, it takes only about 13 GB.
Okay.
But if I don't restrict it, it very soon occupies 100%. So what I do is I use TGI as a deployment, and I pass this environment variable that says, CUDA memory fraction is 0.5.
Interesting.
Right. Okay.
Okay.
And
Like it's great that TGI
that's
allows you to do that, right?
Yeah, and behind the
Yeah.
scenes, it is PyTorch that is actually exposing that. But all you have to do is just set this command line parameter for the arguments, and that's it.
Mhm.
You can basically restrict. And can you believe on my 4 GPU 2 node cluster, I run 9 models.
Whew.
Oh,
Okay.
very cool. Yeah.
That's a good return on investment, right?
Absolutely. I run embedding models, I run state of the art 7B models, and my GPU utilization is 110%. I very, very carefully optimize the GPU cores, and I'm able to run all this. So that layer is super critical. Uh,
Mhm.
Now, apart from TGI, your next choice is something called VLLM. So VLLM
Mhm.
is another inference engine optimized for exposing LLMs as endpoints.
Yep.
You can use that. I haven't used it myself because I've been too busy tinkering with TGI and getting it running on my cluster, but that's a very good choice.
Mhm.
Uh, for example, VMware's private AI is built on top of VLLM.
Okay.
Google has officially standardized on VLLM for GKE. Um, so it's a very proven framework. The third one is from NVIDIA, which is TensorRT LLM.
Mhm.
Not in a specific order, but just my recall. So
Yep.
TensorRT
Yeah.
LLM is a pretty good inference engine. So NVIDIA has optimized TensorRT for transformers, and they surfaced this entire thing. And of course, Olama. Olama is one of the things, but running Olama on Kubernetes is a little bit of a hack. Olama is designed to run on your
Yep.
desktop, particularly on Macs.
Yep.
Right.
Not really meant for Linux and Kubernetes. It's a nifty tool if you want to play around with chatbots on your local machine, but um, it's not a big deal or a difficult task to run Olama on Kubernetes. But
Yeah.
it doesn't really have any knobs, buttons, and sliders to drag around.
Right.
Yep.
There are no tweaks. And then there is a very complex framework called Ray.
Yeah.
Ray is very popular, very well known. It's more of a scheduler,
Mhm.
um, and that runs on Kubernetes. And Ray is used in production by many inference as a service providers.
Got it. And these inference engines that actually serve the model, they give you that endpoint within the cluster, but you still sort of need the client side of things, right? Inferencing is not the inference side of things isn't the thing that the end kind of user or system would interact with, right? That's the chat bot or that's the something else, right? It's the
Exactly.
kind of yeah.
Exactly. So, but the good news is these inference engines expose OpenAI compatible API. So if I'm
Mhm.
already talking to OpenAI, I can change the endpoint and I can actually talk to my local LLM, which is like
Right.
a great use case.
Yep.
Right. Change the endpoint or even write something yourself, right? Because those APIs are there if you are so ambitious. I guess
Exactly.
to say that the
And
uh,
coming back to TGI, one of the reasons why I really love that is LangChain, which is a middleware. I'll
Mhm.
come to that. Think of it like the developer middleware or a developer framework to consume. It's like ODBC for LLMs. You can swap LLMs while keeping your API consistent. So the TGI endpoints are supported by LangChain. So if you are writing your client-side code on LangChain, the beauty is you can keep the endpoint as is, but behind the scenes, you change an entry in config map and reload the pod. You switch from Mistral to Llama to Gemma, with the client doesn't even getting
Oh
restarted,
wow.
or yeah.
Okay.
oh nice. Yeah.
So what I do is I write a config map, and this config map is injected as an environment variable into the pod, and that's the model name which the inference engine picks up. So what I do is I go change this config map and restart the pod. It picks up the new environment variable and it starts serving the new model that I just downloaded from Hugging Face. And the client continues to just run without even knowing that
Right.
the model has been hot swapped. So that is the beauty of TGI again, because of the LangChain integration and the client compatibility.
Okay. I think
CGI
those are
sounds
some great tools, right?
yeah.
I need to go and play with TGI a bit more. I have some experience
Well,
with Olama, some experience with Cubre. But yeah,
Yeah,
I think
we'll create a list of
yeah.
these in the show notes too, right, afterwards, so that people interested in all these terms that we're throwing out, sort of peppering you with, you'll be able to go back and kind of look at them a little bit more.
Okay,
So,
and so go ahead.
yeah, let's switch gears a little bit since we're towards the end of our time here. Why, this is sort of an introduction to how things are running on Kubernetes, but we do want to talk about, what are some of the use cases, especially for maybe your home lab that you're building this particular kind of architecture for. What are the use cases you're looking at, or how do people, consume AI in their daily life? Maybe that isn't a chatbot.
Yeah, absolutely. So my end goal when I built this infrastructure was to run the retrieval augmented generation pipeline end to end. I can pull the plug, my router's plug. I am disconnected from internet, and I can still
Right.
run RAG pipelines with no dependency on internet at all. Um, so what I do is on my cluster, I run LLMs, I run embedding models. Embedding
Mm-hmm.
models are a very critical piece of the puzzle. What they do is they take your sentences or phrases or pages of a document and convert
Mm-hmm.
them into contextual low dimension vectors.
Yep.
And they store and they give you this output that is stored in a vector database. And my favorite vector database is Chroma. It is not a distributed, it cannot be a stateful set because it is not a distributed database, but
Mm-hmm.
Chroma in itself is very simple. So I run embeddings model on GPU, and what I do is I run MinIO as my data lake. So MinIO is my unstructured
Mm-hmm.
storage bucket. I put all the PDFs
Mm-hmm.
there, and I wrote this nice webhook based on MinIO. As soon as I drag and drop a PDF, it actually calls a webhook, and the webhook takes this PDF, slices that into every sentence, sends it to the embedding model. Embedding model gives a bunch of vectors. I push
Mm-hmm.
those vectors into Chroma.
Okay.
And later on, when I search for a specific phrase, basically Chroma gives me back the top k results that semantically match what I'm searching for.
Cool.
And I get it back, and I use that as a context, and I send it to the LLM saying, "You have this grounded, factually correct data, and here is my question. Look up what is in the context and answer. And if you don't know, say I don't know, but don't hallucinate." Right? I explicitly use that in the prompt, uh, and my LLM comes back with a very accurate answer. And the beauty is, with RAG, you can use an extremely a low a small language model, like, so there's something called phi 2 from Microsoft, which is only 1.5 billion parameter. Even that behaves well. It becomes a well behaved LLM when you feed sufficient context to it.
Yep.
uh,
And
so
what does RAG stand for? I know we probably won't go into depth in this, but just for context, since you mentioned
retrieval
it.
augmented generation. So basically, if you go to ChatGPT and ask a question like Oscars that happened yesterday,
Yeah.
ChatGPT cannot answer. But
Right.
if you go to like msnbc.com, copy paste a blurb that has all the award winners, you paste that and say, now look up the data and tell me who is the winner. It can tell
Oh,
you. So
right.
what you're basically doing is you're injecting context into the prompt.
Mm-hmm.
So instead of manually copy pasting, you're building a pipeline that basically takes your query, looks up a database, grabs the relevant context, injects it into the prompt, sends the context plus the prompt to the LLM. That is what is called RAG, retrieval augmented generation. So we are augmenting the prompt with context.
Got it. Yeah, I mean, that's a very powerful thing, I think, as we start to get to using AI tools in real
Mm-hmm.
time, right? You could think about, something about booking flights, or things that aren't historical, right? I imagine that's a big, and I think it is, right. If you kind of look at what's going on in the AI space, there's a lot of talk about RAG and those kind of things. So I think we could probably spend an entire another podcast just on
Yep.
RAG. So we won't go into into that just yet, for sure.
No, I think Ryan, as you said, right? Like we have so many other questions on our notes that we wanted to bring up, but this has already been like a great episode and a great use of our times. Jani, like I know you have like a plethora of resources. I love your YouTube channel. Like, why don't you go ahead and plug all of that information in, and then also point people towards any more resources that you would think will be helpful to people that are just getting started?
Yeah, as soon as I'm back from KubeCon, I'm starting a series on GenAI cloud native infrastructure for GenAI. Every episode will focus on one of the layers. So I have a cake diagram of all the
Okay.
layers of the stack, and every episode focuses on one specific layer of this cake. And I go into the depth. I show commands. I point to GitHub repo where you can actually run shell scripts and set it up by yourself.
Oh, that's going to be super helpful. Like, thank you. Like, it is difficult, right? Like, even though AI is like the new thing, but finding resources that are actionable and something that you can implement on your own is really difficult. And I'm talking from my personal experience here.
Yeah.
So yeah, listener, you heard it here first. Head to Johnny's YouTube channel. We'll put it in the. Well, actually, why don't you? Yeah. Wait, is there a name that it goes by that people can go search you up by, or just your name?
Jani.tv.
Johnny.tv. There we go.
Jani.tv. Yeah.
Yeah.
Perfect. Well, Johnny, it's been a real pleasure having you on the show. I know we covered a lot today, so thank you for packing it into this hour for our listeners. It sounds like we'll have to have you on again in some future time frame to see where all this has, been and what you've been up to, and kind of, I imagine it's going to be one of the fastest growing topics that we have to talk about here on the show too. But yeah, thank you again for coming on the show and kind of diving into this from the Kubernetes perspective with us.
My pleasure. Thank you. It's been a fun conversation.
All right, Bhavin, that was a jam-packed episode, I'll call it, and probably we only touched on like 2/3 of the actual questions we maybe wanted to get to, and I know Johnny kind of joked when we first got on the call. He's like, "There's way too many, there's way too many questions." I think we just got excited because it is an exciting topic, and hopefully you as a listener sort of learn something. But let's just jump into a few takeaways from our perspective. Why don't you take it off?
No, I think I really liked the episode, right? Like, even though we had so much to talk about, there were so many awesome nuggets of information that make things tactical. I think like the vision, like you'll find a lot of podcasts. I know we did like a 101 episode and everybody likes to talk about it from a higher level. But I know I've been following Jani through his blog post and his LinkedIn post and his YouTube channel for a while, and he has been hands down or heads down into GenAI on Kubernetes. So it was great getting his perspective. Like I really liked how you had us break down his entire home lab setup. Like what are the GPUs, what plugins did he install, what projects is he using. That makes it real, right? Like, because there's a lot of buzz around, but how do you get started with this? I think that's my key takeaway from this episode. Like there isn't one. There is like you have to listen to this whole episode once, if not twice, to get everything out there. And then just a fun takeaway was there were so many keywords and project names that we used. Like if we were playing the SEO game, which we don't, like this episode would rank high up there, dude. So I think I really like that episode, that this episode specifically for a practitioner's view on GenAI on Kubernetes.
Yeah, no, I mean, that's a really good point. I was kind of thinking along the same lines of, today, especially when you hear about AI or Gen AI, people are talking about it from a mile high, right?
Yep.
They're talking about the power it can bring you. It's going to change the world.
Yeah.
And someone like me or you is sitting there like, yeah, but how does it work, right?
Yeah.
How do you get it running on this? And I think that's one of the most valuable things.
Yep.
And particularly the pieces that are specific to if you wanted to build this thing in your own lab, right? So he's got a very unique perspective. With the challenges around running 9 models on 2 GPUs isn't the most straightforward thing to do, but it is capable. The fact that it is a challenge to get GPUs for your applications. So sometimes putting up the capex to buy a few mid-range SUVs, GPUs and computers to get you going, and you can work offline might be something you're interested in. So really cool perspective from Jani today that I think a lot of folks hopefully will appreciate. And if you do, drop us a note in the Slack to say, hey, we want to do more of this. I know it's Bhavin and I's goal to do a lot more on this topic because, it's endless. We mentioned a little bit about RAG frameworks at the end, which is actually a really interesting topic all by itself. And we didn't even touch on it. We just kind of told you what it is, right? So, expect more of this, or if you're in this space as a professional or as a user or as a developer, come talk to us. We'd love to talk to you. So, that's my takeaway.
Awesome. Yeah, I think one more shout out that I have for our listeners is, if you are based in the New York tri-state area, or like if you are traveling to New York in May, there is an awesome community event called Kubernetes Community Days, or KCDs. I think it's the first time KCDs are happening in US, and obviously they couldn't have picked a better location. It's on May 22nd, but one thing that we have special for our listeners is, if you are registering for it and you use the code Kubernetes Bytes, you get a 10% discount right there and there. So if you are going to the event, or if you were on the edge, hopefully this 10% discount gets you over that edge and you register for that event. But yeah,
if
that's
not,
a quick
it's an
shout out.
excuse. Yeah, if not an excuse to go visit New York City, I guess. So I know there's a lot of KCDs in Europe, so really cool to see one happening now in New York City. And from what I've seen of them in Europe, they're really great events. So go check it out, which I believe is Wednesday, May 22nd. It's a Wednesday. I could be off.
Oh,
It's right around there or something like that.
Okay.
All right,
Nice.
Bhavin. So that brings us to the end of today's episode. I am Ryan.
I'm Bhavin.
Thanks for joining another episode of Kubernetes Bytes.
Thank you for listening to the Kubernetes Bytes podcast.